Welcome to the Deep Dive. You're here because you want to get smart, fast on aviation weather service as well. You've definitely come to the right place. We've got a lot of material here, and our aim is really to cut through all the complexity.
Yeah, make it understandable.
Exactly.
Yeah.
So you walk away with a solid grasp of, this really vital topic. Think of this as your shortcut to weather wisdom.
And it's a huge topic. What really jumps out is just the sheer scale of it all. Aviation weather services. It's not just one group.
No, definitely not.
It's this massive, coordinated thing. You've got the National Weather Service, the FAA, the Department of Defense,
Right.
and loads of other aviation organizations here and, internationally too,
Yeah.
all feeding into this stream of information.
It's easy to forget how far forecasting has come, actually.
Oh, absolutely. Years and years of scientific study, plus these incredibly powerful computer models now.
Means they're just getting better and better predicting what's heading our way. More accurate.
And all that science, all that data crunching, it's ultimately for pilots like you, right?
Yeah.
Mm-hmm.
So this deep dive, we're really focusing on how pilots get hold of and actually use all that weather intelligence.
Through all the different reports and forecasts available.
Yeah, exactly. The whole point, of course, is making informed decisions.
Yeah.
Keeping flights safe.
Before you even start the engines and while you're up there.
Precisely.
So we're going to look at the whole chain. From how they first observe the weather to the different ways pilots get that info, and crucially, how they interpret it and, apply it.
Our sources cover pretty much everything. Observations, forecasts, the service outlets, getting briefings, the lot.
Okay, great. Let's unpack this then. Starting right at the beginning, weather observations.
Makes sense. Because every single forecast, every advisory, all the guidance you get, it all starts with observations. Someone or something looking at what the atmosphere is doing right now.
Right.
And we could basically break these down into four main types. You've got surface observations, upper air observations, radar, and satellite stuff. Okay, let's start right down on the ground then. Surface observations. I think most pilots know these as METARs, right?
That's the one, yeah. Think of a METAR as like a snapshot. Real-time weather at a specific airport.
Just at that one spot.
Yeah, at that station. All across the country, you've got these monitoring stations, some government, some private, constantly churning out these reports.
And automated systems, too, like
Right.
AWAS and ASOC.
Exactly. They play a huge part in gathering and sending out that surface data. So a METAR gives you that immediate picture of the critical conditions right there at the field.
So it's like sticking your head out the window at the airport, but, more technical. What kind of details are we talking about?
Oh, it's packed. Really dense with info. It starts with the type of report. Is it the regular scheduled one or a special one issued because something changed quickly?
Okay.
Then the airport code, that 4-letter ICAO identifier, like KGGG for Gregg County. You see the K usually in the contiguous U.S.
Right. And PA and Alaska, PH in Hawaii, I think.
That's it. Then the date and time, always in UTC, Zulu time.
Gotta watch that time zone conversion.
Always. Then maybe a modifier like auto if it's automated, or COR if it's a corrected report. Then the wind, crucial stuff.
Direction, speed?
Yep, direction it's coming from, speed in knots and any gusts. Also, the direction is variable.
And visibility, how far you can see it.
Reported in statute miles.
Yeah.
Sometimes you'll get RVR too, runway visual range, which is specific to seeing down the runway.
Okay, wind visibility. What about the actual weather, like rain, clouds?
That's under weather phenomena. It uses standard codes, tells you about intensity, light, moderate, heavy proximity, descriptors like showers or thunderstorms.
TS for thunderstorms, RA for rain, that kind of.
Exactly. Like plus TSRABR means thunderstorms with heavy rain and mist. Then comes sky condition.
How cloudy is it?
Yeah, how much of the sky is covered, usually in eighths, like BKN for broken, OVC for overcast, and the height of the clouds above ground level, AGL.
So BKN 008 is broken clouds at 800 feet.
You got it. And it might mention cloud type, like CB for cumulonimbus, those big thunderstorm clouds. If the sky is totally obscured, you'll see VV for vertical visibility.
Right, like in thick fog.
Mm-hmm.
What else is critical in a METAR?
Okay, temperature and dew point, both in Celsius, super important for fog, icing potential. Altimeter setting in inches of mercury usually starts with an A. Pilots need that to set their altimeters correctly.
Yeah, crucial for altitude accuracy.
And finally, the remarks section. RMK, this can have loads of extra detail. Variable winds when weather started or stopped, maybe pressure changes like pre-SFR for pressure falling rapidly.
Or pre-SR for rising rapidly.
Right. Even lightning activity. OCNL LTGICCG means occasional lightning in cloud and cloud to ground. Automated stations might add remarks about maintenance needed too.
So the key is, it's an instant snapshot of surface conditions right there. Helps you see if it's even VFR.
Precisely. Quick assessment.
That is a lot packed in. Let's look at that example again. METAR, key GGG 1617530Z, auto 140 and G26KT 34SM plus TSRA, BRA, BKN 008, OVC02 row CB, A2970 RMK pre-SFR. If you're scanning that quickly, what jumps out?
Okay, quick scan. KGGG, that's the place. 34SM visibility. Oh, that's IFR.
Right, less than a mile.
Plus TSRA, BR, thunderstorms, heavy rain, mist, definitely hazardous.
Big red flag.
BKN 008, OVC 012CB, low clouds, broken at 800 feet, overcast at 1200, and those CBs, the thunderstorm clouds, another major concern. A2970, that's your altimeter setting. And pre-SFR in remarks, pressure falling rapidly often means weather's getting worse.
So bam, 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 visibility, storms, low clouds, immediate concerns.
Exactly. That quick scan tells you a lot about the immediate situation.
That perspective helps. So one METAR is just one spot, but if you look at a bunch of them along your route,
then you start to build a bigger picture of the surface weather landscape.
Makes sense. Okay, let's move up. Upper air observations. You said this is trickier.
Yeah, getting direct measurements way up high isn't as easy as planting a weather station on the ground. We have to use different methods.
Like what?
Things like radio sons, those are the instrument packages on balloons, pilot weather reports, PIREPs, super important, actual reports from pilots flying.
First-hand accounts.
Yeah, and then automated systems on commercial jets like AIMDR and MDCRS.
Okay, let's talk about those radio sons first. Balloons with instruments.
Pretty much. It's a small box of instruments hanging below a balloon, usually filled with hydrogen or helium.
And it just floats up.
Yep, rises at about 1,000 feet per minute. While it's going up, it's measuring temperature, humidity, pressure. And by tracking the balloon's path, we figure out wind speed and direction at different altitudes.
And how does the data get back down?
It's got a small radio transmitter, sends the data back to a ground station.
How high do these things go?
Pretty high, up to around 115,000 feet sometimes.
Wow.
And they can drift a long way, maybe 125 miles over a couple of hours. Conditions up there are extreme. Think minus 130 Fahrenheit, almost no air pressure.
So the balloon just keeps expanding.
Right, until it's huge, maybe over 20 feet across, and then bump.
And the instruments just fall.
Well, there's a small parachute, so it comes down slower. About 20% actually get found in return, believe it or not. There are instructions on them for mailing back.
Huh, interesting. Okay, what about PIREPs? Pilot reports. You said they're the only source for some things.
Absolutely vital point. PIREPs are reports from pilots in the air right now. They give us real-time info on stuff like the actual bases and tops of clouds.
Stuff you can't see from the ground.
Exactly. And crucially, turbulence, where it is, how bad it is. Same for wind shear and icing. No ground sensor or radar can tell you exactly where the ice is forming right now.
Only a pilot flying through it.
Precisely. ATC actually asks for PIREPs at the ceilings below 5,000 feet or visibilities under 5 miles. But pilots are really encouraged to report any unexpected or nasty conditions they hit.
And that info gets shared.
Immediately. Goes into the system, helps other pilots, helps forecasters issue warnings like AIRMETs and SIGMETs. It's a critical safety loop.
So my report of moderate chop could warn the plane behind me. That makes sense. What about AIMDAR and MDCRS, those automated systems on airliners?
Right. These use commercial flights as moving weather stations, basically. AMDR is the international one.
Okay.
Airlines put sensors on their planes to measure wind, temperature, humidity, even turbulence and icing sometimes.
And it just sends the data automatically?
Yeah, through data links, either VHF radio, that's ACARS, or satellite links called ASTAR. It generates a huge amount of data, hundreds of thousands of observations every day globally. Really boosts forecast accuracy.
And MDCRS is the U.S. version?
Yep, meteorological data collection and report system. Same idea. Domestic U.S. airlines participate, sends real-time upper air data via ACARS managed by Aeronautical, then off to the National Weather Service and others.
What data does it collect?
Mostly wind and temperature from over 1,500 U.S. drones. Some report turbulence and humidity too. It's gathered by the plane's own data systems. If they're out of ACARS radio range, it might get stored and sent later or relayed via satellite if they have ASTAR.
So wow, a really complex network of eyes on the ground and in the sky, constantly feeding data back.
That's the foundation.
Okay, let's switch gears to radar observations. Seems like there are a few different types pilots might encounter.
Yeah, four main ones relevant to aviation. There's the WSR-88D, which is the main Doppler network, then TDWR, terminal Doppler weather radar near big airports, FAA airport surveillance radar, and finally airborne radar on the plane itself.
Let's start with the WSR-88D. That's the classic Doppler radar we see on TV weather, right? Why is it useful for pilots?
It's a powerful system. Uses the Doppler effect not just to see where rain or snow is, but how it's moving. That gives us wind information inside storms.
Is it different modes?
Yes, two main ones. A clear air mode, which is very sensitive for picking up faint returns like dust or even bugs, helps see wind shifts or boundaries. It scans slower, updates maybe every 10 minutes.
Okay.
Then there's precipitation mode. Uses stronger signals, scans faster, updates every 4 to 6 minutes. Better for tracking storms as they develop.
And the colors we see on the display show intensity.
Exactly. Intensity is measured in dBz. Those values correspond directly to terms ATC and pilots use. Light, moderate, heavy, and extreme precipitation.
Got it. And TDWR, terminal Doppler, where are those used?
Those are specifically placed at major airports. Their main job is alerting controllers to immediate close-in hazards like wind shear, gust fronts, microbursts, heavy precipitation, things really dangerous during takeoff or landing.
Okay, very localized protection. What about regular FAA airport surveillance radar, the one tracking planes? Does it see weather too?
It does. Its primary job is tracking aircraft, obviously for separation. But it also detects precipitation, shows controls where it is, and gives some idea of intensity, helps them route planes around nearby storms.
And finally, airborne radar. That's the pilot's own system.
Correct. Radar installed on the aircraft gives the pilot a real-time view of weather ahead of them.
What's the advantage there?
They typically use C or X band frequencies. These can penetrate heavy rain better, letting pilots see the structure and extent of thunderstorms. They also pick up less intense precipitation that might still be a factor.
So radar shows precipitation, wind within storms, and airborne gives a forward look. That leaves satellites. What do they add to the mix?
Satellites give us the really big picture, viewing weather systems over huge areas, and the technology's improved so much that now pilots can actually get near real-time satellite weather images directly in the cockpit, usually through subscription services. Covers pretty much all of North America. It's great for overall situational awareness.
Okay, so we've covered how weather is observed. Now, how does a pilot actually get this information? Let's talk about the service outlets.
Right. Service outlets are basically the places government, contract, private companies authorized to give out aviation weather services.
Who are the main players?
The big government ones are the FAA, NOAA, and the National Weather Service, NWS. They often work with private aviation companies, too, offering different ways to access the data.
Let's start with the one most pilots probably know best, the Flight Service Station, or FSS.
Yeah, FSS is still a primary source, especially for pre-flight weather info. You can call 1-800-WX-BRIEF 247, get a full briefing from a specialist.
From anywhere in the U.S.?
Yep, U.S. and Puerto Rico. You can find specific FSS numbers in the Chart Supplement U.S. or even the government pages of the phone book.
And they do more than just pre-flight, right?
Oh, yeah. They also provide in-flight briefings and issue weather advisories for pilots already flying in their area.
So ground and air support.
Yeah.
What about TABS, Telephone Information Briefing Service? Sounds automated.
It is. TABS is their FSS too, but it's automated recordings. Gives you meteorological and aeronautical info.
Like what kind of info?
Could be area or route briefings, maybe details on airspace procedures, special announcements. It's updated automatically when new info comes in.
Is it a substitute for talking to a person?
No, definitely not. It's more like a preliminary tool, get a quick overview, shouldn't replace a full briefing from a specialist. And you need a touch-tone phone to use it. Numbers are in the chart supplement.
Okay, a quick check tool. Then there's HIWAS Hazardous In-Flight Weather Advisory Service. How does that help pilots flying?
HIWAS is for the lower 48 states. It's an automated, continuous broadcast of hazardous weather info. Think AIRMETs, SIGMETs, convective SIGMETs, urgent PIREPs.
Broadcast over what?
Over certain VOR navigation aids, it's updated automatically too.
So you just tune in the VOR?
Kind of. If you hear something worrying on HIWAS, the idea is you then contact FSS or maybe EFAS en route Flight Advisory Service, Flight Watch for the full details and advice.
How do you know which VORs have HIWAS?
On your aeronautical charts, look for an H in the upper right corner of the VOR identification box. That means it broadcasts eyes.
Got it. Like a constant weather alert channel in the background. Lastly here, TW transcribed weather broadcast. This is Alaska only.
That's right. TWEB is Alaska's version of a continuous automated broadcast. Uses some low-medium frequency beacons and VORs.
XI?
Similar stuff, updated automatically. Adverse conditions, surface observations, PARBs, maybe density altitude if it's high. Could include a synopsis, winds aloft, forecasts, radar reports.
Can you get on the phone too?
Some locations have tell TWEB, yeah. Phone numbers are in the Alaska chart supplement. But again, like TBES, it's mainly for planning, not a substitute for talking to a specialist.
Okay, so several ways to tap into the info stream. Now let's focus on the briefings themselves. You talk to FSS, you need to ask for the right kind, right? Standard, abbreviated, or Outlook.
Exactly. Ideally, get a briefing before every flight. And when you call, tell the specialist what type you need.
What else helps the briefer?
Oh, definitely tell them if it's VFR or IFR, your aircraft ID and type, departure point, estimated departure time, planned altitude, route, destination, and how long you think the flight will take.
Why do they need all that?
Well, it helps them tailor the briefing just for your flight. Plus, they record that info.
Yeah.
It gets used if you file a flight plan, and crucially, if you end up overdue or missing, it helps search and rescue.
Ah, okay. Good reason. Let's start with the standard briefing. When do you ask for that?
Standard is the full meal deal, most complete picture. You want this for your main pre-departure planning.
What does it cover? Is there a specific order?
Usually, yeah, if it applies to your flight. They'll start with adverse conditions, big weather issues, airport closures, then maybe a VFR not recommended statement if conditions look bad.
Okay.
Then a synopsis, the big weather picture. Current conditions if you're departing within 2 hours. And route forecast for your flight path. Destination forecast.
Winds aloft, too.
Forecast winds and temps aloft, yeah. Temps usually only if you ask specifically.
Whoa.
NOTATAMS notices to airmen, important safety stuff, again, often need to ask for published ones specifically. ATC delays, and then any other relevant info like radio frequencies for flight plans or EFS.
Sounds very thorough.
Kids.
Essential before you go.
Yeah.
What about an abbreviated briefing?
Abbreviated is shorter. You use this if, say, your departure gets delayed and you need an update, or if you already got a standard briefing earlier and just want the latest changes.
Do you need to tell them about the previous briefing?
Yes, definitely. Tell them when you got it and who gave it to you. If you know, helps them avoid repeating stuff and just focus on what's new or what you missed. Good practice to get updates whenever you can, especially after a delay.
Makes sense. And the Outlook briefing. Sounds like for planning way ahead.
Exactly. Use this if your planned departure is 6 hours or more away. It's more general. Gives you initial forecast trends, major weather systems expected near your departure time.
So it helps with early decisions. Go, no go, route, maybe.
Yeah, influences those initial thoughts. But because it's so far out, the forecast is less certain. So it's really prudent, essential actually, to get a follow-up standard briefing closer to departure time for the latest, most accurate picture.
Got it. Briefings tailored to your planning stage. Okay, let's shift from forecasts back to the now. Aviation weather reports. Snapshots and current conditions. We covered METARs already. What's the other key one?
Besides METARs, the other absolutely critical report is the PIRE-EP, the Pilot Weather Report.
Right, we touched on them for upper air data, but they stand alone as reports too.
Exactly. They provide that unique, invaluable perspective, what's actually happening in the air.
Things METARs can't see.
Right. Actual cloud bases and tops, where turbulence or wind shear really is and how bad, where icing is actually occurring. ATC, as we mentioned, is supposed to ask for them when ceilings or Vs are low.
And pilots should just volunteer them too.
Absolutely encouraged. Report unexpected stuff, hazardous stuff to FSS or ATC. It gets put right into the system, warns other pilots, helps trigger advisories. It's a huge safety contribution.
Filing them isn't too hard, right? Is there a standard format?
Yeah, there's a standard format to make sure key info is included. Usually starts with type routine UA or urgent UUA, then location relative to a VOR or airport, time in UTC, altitude or flight level. Aircraft type helps interpret turbulence reports, for example.
Like light chop in a 747 is different than in a Cessna.
Exactly. Then sky cover, weather encountered, temperature, wind, turbulence, icing, and any remarks. Sometimes they get tacked onto surface reports, but usually they're individual. The codes are mostly self-explanatory.
Let's look at that example again. UAOV GGG 090025TM1450 data 00K 060TP, CO90TP, 0990, 05TP on 1 for CTRM, HVY rain. Break that down for us.
Okay. UA routine report, OVGGG 0900025, locations 25 nautical miles out on the 090 radial from Gregg County VOR, TM 1450, time 1450 Zulu, FL 060, altitude 6,000 feet, TPC 182, aircraft Cessna 182, SK0A0 OVC, sky condition overcast at 8,000 feet, WXFV04 SMRA, weather is flight, visibility 4 statute miles and rain, TA05, temperature 5 degrees Celsius, WV 27000 KT, wind is from 270 degrees magnetic at 30 knots, no magnetic, not true like METARs, TBLGT, light turbulence, RM, HVY rain, remark the rain was heavy.
So clear picture, 8,000 overcast, V's 4 miles in heavy rain, light turbulence, wind 270 at 30, temp 5C at 6,000 feet, 25 miles east of GGG. Very specific.
Incredibly useful for the next pilot heading that way.
Absolutely. Okay, METARs for surface, PIREPs for inner reality. Now let's look ahead again with aviation forecasts, using those observations to predict the future for planning.
Right. Observations feed the forecasts. For printed forecasts pilots need for planning, the main ones are TAFs, terminal aerodrome forecasts, FAs, area forecasts, those in-flight advisories, SIGMETs and AIRMETs, and the FEO, winds and temperatures aloft forecast.
Let's start with TFs, terminal forecasts. They're for specific airports.
Yeah, specifically for the area within about 5 statute miles of larger airports, usually valid for 24 or sometimes 30 hours, updated 4 times a day, 00Z, 06Z, 12Z, 18Z.
And they use the same codes as METARs.
Pretty much, yeah. Same descriptors, abbreviations. If you can read a METAR, a TAF looks very familiar. Makes it easier to compare current conditions to the forecast.
What info is in a TAF?
It starts with the type. TAF, or TAF AMD for amended. Then the ICAO station ID. Date time of origin, Zulu. Valid period, date time to date time. Then forecast wind, direction true north, speed knots. Forecast visibility, statute miles, P6SM means greater than 6. Forecast weather, same format as METAR. Forecast sky condition, similar to METAR, but only specifically mentions CB clouds. And then, importantly, forecast change groups.
Change groups, like when things are expected to shift.
Exactly. FM means from, indicates a rapid, significant change expected around that time, lasting till the next change group. Tempo means temporary fluctuations expected during that period, each lasting less than an hour, covering less than half the period overall.
Any others?
Sometimes PRO 030 means a 30% probability of thunderstorms or precipitation during that specific time window, though they don't usually use PRO 30 in the first 6 hours of a 24-hour TAF.
Okay, let's look at that KPR example TF again, focusing on the changes. KPR 11130Z at 1012114, 5SM, BR FM 12000, 16015G 25KT, P6SM, BK01250, FM 120, BKN 250, FM 120 CBR, OVC 150, Prob 30, 124, 3SM TSRA, Beacon 00 CB, FM 11304, P6SM, SCT 040, OVC 010, Tempo 120 41208, 3SM TSRA, OVC 030 CB. Walk us through the flow. Okay, valid from 12Z on the 11th to 12Z on the 12th. Starts with temporary low-vis, 5SMBR, between 12Z and 14Z. Then FM 120,000 from 000Z on the 12th. Winds shift, slightly weaker, lower clouds return, BKN 080, VC 150. Then P-roll purity between 000Z on the 12th. Chance of thunderstorms, 3 miles visibility, low CD clouds. After that, FM 120 to 150. Winds ease more, conditions improve slightly. SCT 040, VC 080, but still temper conditions between 040 and 08C with possible thunderstorms and low overcast. 3SM TSRA, OVC 030 CB.
So it paints a picture of changing conditions over the 24 hours. Some temporary issues early, improvement, then a period overnight with potential storms, followed by gradual improvement with lingering storm chances.
Exactly. Reading the change groups tells the story.
Very useful for timing flights. Okay, TAFs for specific airports. What about area forecasts, FAs? Much bigger regions, right? When are they most useful?
Yeah, FAs cover large areas, multiple states usually. 6 areas for the contiguous U.S. They give a picture of clouds, general weather, and VMC conditions. Issued 3 times a day, valid 18 hours.
So good for en route.
Perfect for en route planning.
Yeah.
Also vital for planning flights to or from smaller airports that don't have their own TF. It's the best forecast you'll get for those spots.
What's the structure? What section should pilots look at?
Usually 4 sections. Header, who issued it, when, valid times, area covered. Precautionary statements, warnings about IFR, mountain obscuration, thunderstorms, clarifies if heights are MSL or AGL-CIG. Synopsis, brief overview of pressure systems fronts, and the main part, VFR clouds and weather, detailed 12-hour forecast plus a 6-hour outlook section.
Let's look at those examples. Header, DFWC FA 120945 synopsis and VFR CLDSWX, synopsis valid until 13400 CLDSWX, valid until 12200, OTLK valid 122 130400, OKTX AR, LA, MSAL, and CSTL. WTRS. What does that tell us?
Okay, DFW Center issued it on the 12th at 0945Z. Synopsis part is good until 04Z on the 13th. Detailed clouds weather part is good until 22Z on the 12th, with the outlook covering 22Z to 04Z. Covers OK, TX, AR, LA, MS, AL, and coastal waters. Sets the stage.
Precautionary statement. See AIRMET Sierra for IFR cons and MTN OBSCN. TS implies SEV or GTR turb, SEV ICE, LLWS, and IFR cons. Non-MSL HGTS denoted by IL or SIG. Key warnings.
Big ones. First, check AIRMET Sierra specifically for IFR or mountain obscuration details. Second, if the forecast mentions thunderstorms. TS, assume severe or greater turbulence, severe ice, low-level wind shear, and IFR conditions are possible, even if not explicitly stated. Huge safety point. And third, it clarifies height references. If it's not MSL, it'll say AGL or CIG.
Synopsis example. Synopsis, low press trough 10Z OKTX PNHDL area. FCSU move into sea draw sworn OK by O4Z. W or MFNT 10Z CN Trail OKSRN MSS lift NWD into NERN OK and RNR extra NS by O4Z. Big picture here.
Tells you the main weather features driving things. Low pressure trough over OKTX panhandle moving east. Warm front over OCARMS lifting north. Helps understand why the weather in the next section is forecast the way it is.
And the detailed part, VFR clouds and weather. SCNTRL and CERN TX AGL SCTBKN 0 Bose SCTBKN 00 Miss IS 35 SMBR 1416Z BK MG AGL SCT03 19Z AGL SCT the OK VFR OK and Delland and the W.AGL SCTB KN 100 top SFL 200 15Z AGL SCT 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 SCTD SDT DVOPG few plus 7 supposed to see top SFL 450 OTLSK.VFR. How do you read that for different areas?
Okay, for south, central, and southeast Texas, starting with low clouds, scattered to broken at 1,000-foot AGL, tops at 3,000-foot MSL, this 3 to 5 miles in mist. Improving later, clouds lifting to 3,000-foot AGL, then 5,000-foot AGL, outlook VFR. For Oklahoma Panhandle and Northwest, starting scattered at 3,000-foot AGL, another layer scattered to broken at 10,000-foot AGL, tops way up at 20,000-foot MSL, lifting slightly later. Then, after 20Z, scattered thunderstorms developing, some possibly severe, tops way up at FL 450. Outlook VFR overall, but watch out for those storms. Note how locations can be states, regions, or features.
Right. Clarifies how to use FAs for broad areas or airports without TAFs. Okay, moving on to in-flight weather advisories. Issued for planes already flying, but good for planning too. AIRMETs, SIGMETs, convective SIGMETs. Let's start with AIRMETs. What do they cover?
AIRMETs are for weather that's potentially hazardous, especially to smaller aircraft or pilots with less instrument experience. Not quite severe, but definitely significant.
Of what kind of conditions?
Things like moderate turbulence or moderate icing. Sustained surface winds of 30 knots or more. Widespread areas where ceilings are below 1,000 feet or visibility is under 3 miles. Extensive mountain obscuration.
How often are they issued?
Every 6 hours, with updates in between if needed. They have standard letter codes, Sierra for IFR and mountain obscuration, Tango for turbulence, strong surface winds and low-level wind shear, and Zulu for icing and freezing levels.
Let's look at the AIRMET Sierra example. Boswebby 211945 AIRMET Sierra up DT3 for IFR and MTN OBCN. Valid until 200-2200 AIRMET IFT, ME, NH, VTMA, ATIINYNJ, and CSTLWTRS from CAR to YSJ to 150E to UTR YO to CAR OCNL SECUGI BLW010M, BLW3SM PZPNBR, Cons Comp BYD 0 Lushu, 0 Duzi or VOZACN, ME, NH, VTMA Oshur 8Z. What's the warning here?
Okay, Boston issued it, BSSS. It's AIRMET Sierra Update 3 for IFR and mountain obscuration. Valid until 02,000Z on the 22nd. Covers 2 things. First, IFR conditions, IFT, over a large area of the northeast U.S. and waters, defined by those Nevade points. Expect occasional ceilings below 1,000 feet visibility below 3 miles in precipitation mist. And it notes these conditions will likely continue past O2Z. Second, mountain obscuration, MTN OBSCM, over mountainous parts of ME, NH, VT, MA, NY, PA. Mountains occasionally hidden by cloud suppressant mist, also expected to continue past O2Z, so pilots in those areas need to be cautious about low conditions and terrain visibility.
Got it. Significant, but maybe not universally hazardous. Now, SIGMETs, WSs, these are for more severe stuff affecting all aircraft, right? but not thunderstorms.
Correct. SIGMETs cover severe non-convective hazards. Think severe icing not associated with thunderstorms, severe or extreme turbulence or clear air turbulence, CAT again, not with thunderstorms, widespread dust or sandstorms lowering visibility below 3 miles, and volcanic ash, very hazardous.
Are they scheduled?
No, unscheduled. Issued whenever these conditions occur or are forecast. Valid for 4 hours usually, but 6 hours if it's related to a hurricane. They get an alphabetic ID, November through Yankee. First issuance is UWS, Urgent Weather SIGMET. Subsequent ones for the same event are numbered.
Example SIGMET. S4WS 100-130, SIGMET Rome 02, valid until 1005 due. WA, from C TDT to UG2C, OCNL, CEFCAT, BTN, FL280, and FL350, EXPCD due to JTCR, CONSPGNG EFT 02CLZ, CONTG BYD 0530Z. What's the danger here?
Okay, SIGMET Romeo 2. Issued by Chicago RTCC. SFOR means it covers their area but could be issued by the Aviation Weather Center. Valid until 053 CRZ on the 10th. Affects Oregon and Washington in that defined area, CRTGUGC. Warning is for occasional severe clear air turbulence between flight level 280 and 350 caused by the jet stream.
Definitely something to be aware of or avoid. Okay, then there are convective SIGMETs, WSTs. These are about thunderstorms.
Yes, specifically hazardous convective weather. Affects all flights. Covers severe thunderstorms, meaning surface winds 50 knots or more, hail 34-inch or bigger, or tornadoes.
What else triggers one?
Also issued for embedded thunderstorms, hidden in other clouds, lines of thunderstorms or areas of thunderstorms with heavy or greater rain affecting at least 40% of a 3,000 square mile area.
Where are these issued for?
Contiguous 48 states only, not AK or HI, divided into Eastern E, Central C, and Western WS regions, usually issued hourly at 55 past the hour, but specials can come anytime, valid for 2 hours, numbered 199 daily starting at 00Z. If there's nothing to report, they issue one saying convective SIGMET.none.
Example, convective SIGMET, MKCC DOEST W1855 convective SIGMET, 20 SIGMET 20C valid until 2055 Z and SD from 90W mod GFKR 90W mod INSFAG area, 17 smoke from 24045 KR, tops AVFL 450, wind gusts to 60 kds Fabridi, tornadoes, hail to 2 inches, wind gusts to 65 kd PAS and BTN. What are the big threats?
Okay, issued by Kansas City, MKCC, for the Central region. It's number 20 for the day, valid until 2055Z, covers parts of North and South Dakota in that defined area. Warning is about an intensifying area of severe thunderstorms moving northeast from 240 degrees at 45 knots. Tops are way up above FL 450, gusts to 60 knots already reported, and potentially tornadoes, hail up to 2 inches, and gusts to 65 knots possible in the North Dakota part. Very dangerous conditions.
Absolutely. Avoid. Okay, last printed forecast. Winds and temperatures aloft. The FB, what's its main purpose?
The FB gives you forecasts for wind direction, speed, and temperature at specific altitudes above various locations across the U.S., including Alaska and Hawaii, based on the radio saw and balloon data collected twice a day, 00Z and 12Z.
How are the altitudes presented?
Below 18,000 feet, they're true altitudes, MSL. At 18,000 feet and above, they're flight levels, MFL. Wind direction is always true north, speed in knots, temp in Celsius.
Are there altitudes where they don't provide data?
Yeah, no wind forecast within 1,500 feet of the station's elevation, and no temperature within 2,500 feet. Ground interference messes with those close-in readings.
And that weird coding for strong winds. How does that work again?
Right. If the wind speed is forecast 199 knots, they add 50 to the direction and subtract 100 from the speed. So 270 degrees at 130 knots becomes 27 plus 50 equals 77 for direction, and 130 equals 30 for speed. Coded as 730.
And you reverse that to decode.
Yeah.
See direction 5186, subtract 50, add 100 to the speed.
Exactly. If the wind is 200 knots or more, they just code the speed as 99, and you still do the direction math, subtract 50, and mentally add 100 to the 99. Calm wind, or less than 5 kilograms, is coded in 9900.
Okay. Let's look at the sample table for AMA, Amarillo, and Denver. How do I read, say, the 9,000-foot forecast for Denver? DEN.
Okay, find the DIN row. Go across to the 9,000 column. The entry is 2,321 and Zoo 4.
So wind from 230 degrees true.
At 21 knots.
And temperature minus 4 degrees Celsius.
Perfect. You just read across for the altitude you care about for each station along your route. Crucial for flight planning, fuel burn, ground speed, potential turbulence.
Definitely. Okay, that covers the main text forecasts. Let's switch to visuals. Weather charts. How do they help pilots?
Charts give you that graphical big picture. Great for understanding the overall weather situation quickly, especially during initial planning. Shows you where the major systems fronts are, how they're moving.
Which charts show current conditions?
For current info, you look at the surface analysis chart, the weather depiction chart, and also parts of the significant weather prognostic charts.
And for the forecast picture?
The significant weather prognostic charts are the main forecast charts.
Let's start with the surface analysis chart. What's on it?
It's an analysis of current surface weather, transmitted every 3 hours, shows highs, lows, fronts, temperatures, dew points, wind direction, speed, local weather, obstructions, all plotted using a station model and various reporting points.
The station model again.
Right.
What are the key parts of that on this chart?
Okay, the circle shows sky cover, filled, empty, partial. Number top right is sea level pressure. Last 3 digits add 10 or 9. Number bottom right is pressure change trend in last 3 hours. Number bottom left is dew point, Fahrenheit. Symbol left of circle is present weather. Number top left is temperature, Fahrenheit. The stick coming out shows wind direction, points where wind is from. And the barb's pennants shows speed, short 5 cutes, long 10 cutes, pennant 50 cutes.
So a compact code for everything happening at that station right now.
Exactly. Lets you see patterns across the map.
What about the weather depiction chart? How is it different?
Weather depiction focuses on visualizing flying conditions based on METARs, prepared every 3 hours. It outlines areas based on flight category.
Like VFR, IFR.
Right. Hatched outline means IFR, ceiling 1,000 feet and/or vs 3 miles. Non-hatched outline means MVFR. Marginal VFR ceiling 1,000, 3,000 feet and/or vs 3 to 5 miles. No outline means VFR, better than MVFR.
So a quick glance shows you where the good and bad flying weather is.
Pretty much. It also shows fronts and troughs from the latest surface analysis chart. Uses a simplified station model, just sky cover, ceiling height, weather obstructions. No wind or pressure usually. Bracket means automated station.
Okay. And the significant weather prognostic charts, you mentioned low level and high level.
Right. Low level is surface to FL 240, 24,000 feet. High level is FL 250 up to FL 630. For most VFR flying, the low level chart is key.
What does the low level prog chart show?
Issued 4 times a day. Shows forecasts for 12 and 24 hours out. Depicts areas of forecast freezing levels, turbulence, and importantly, contours outlining expected areas of MVFR and IFR conditions. Low ceilings visibility.
So it's a forecast map of potential hazards.
Exactly. Lets you pictorially see where problems might develop. Great for initial planning, comparing potential routes, but always check current conditions and detailed forecasts too. There are also 300 and 648-hour surface prog charts showing pressure patterns, fronts, and precipitation further out.
Charts give that crucial visual context. Now, what about ATC radar? What can controllers actually see?
ATC radar sees precipitation, can often tell intensity but not type. Rain versus snow versus hail, so they just call it all precipitation.
Do they have speckle systems?
The high altitude centers, RTCCs, use warp weather and radar processor. It mosaics data from multiple NEXRAD sites, gives a bigger picture, but the data can be up to 6 minutes old by the time the controller sees it.
How do they describe intensity?
If their system shows it. Light, moderate, heavy, or extreme. Older systems might just show moderate and heavy to extreme. If they can't see intensity, they'll just say intensity unknown and give you the location.
Can they see turbulence?
No. ATC radar cannot detect turbulence directly. They might warn you to expect it near heavy precipitation or thunderstorms because turbulence is often associated with those, but they can't actually see the bumps. Avoid thunderstorms by a wide margin, like 20 miles, because severe turbulence is implied.
So useful for general precip areas, but limited. Can pilots ask ATC for help avoiding weather?
Yes, absolutely. Controllers will issue pertinent weather info and help with avoidance deviations, reroutes, altitude changes, radar vectors if they can do it without compromising their main job, keeping planes safely separated.
But sometimes they might be too busy.
Exactly. During bad weather, workload goes way up. Radar limitations, frequency congestion can also limit how much help they can give. So ask for help, but don't rely on it as your only plan. Be proactive yourself.
Good advice. Okay, let's talk cockpit tech. EFDS, MFDS, electronic flight displays, multifunction displays. Showing weather right there. What kind of stuff is available?
A lot, depending on the system and subscription. Graphical NEXRAD radar is common. Graphical and text METARs, text TAFs, city forecasts, graphical winds aloft, echo tops, cloud tops, lightning strikes, storm cell movement, SIGMETs, AIRMETs display, surface analysis charts, freezing levels, even TFRs sometimes.
Wow, a whole weather briefing suite in the panel.
Potentially, yeah. But pilots must be familiar with their specific system, what data it shows, and importantly, its limitations.
You mentioned limitations. One big one is the age of the data. Right. It's not truly real-time.
Critical point. It's near real-time at best, not instantaneous. Every product usually has a timestamp showing its age when it was packaged on the ground, usually in Zulu time.
And that's not necessarily when it got to the plane.
No, it's the minimum age. Could be older. Current weather, like radar, shows age in minutes. Forecasts show their valid time period. You have to pay attention to those times. Don't make decisions on old data.
Let's focus on XRED in the cockpit. That delay, how bad can it be?
It's significant. The NextRed system itself updates every 4-6 minutes or so in preset mode.
Yeah.
Then the data gets processed, stitched together, sent up to the plane. The image you see could easily be 5 minutes old, maybe more.
Has that caused problems?
Sadly, yes. NTSB has cited accidents where pilots seem to rely on NextRad images that were 6 to 8 minutes old. Factor in storm movement, and the real weather could be 15-20 minutes different from what's on screen.
So the takeaway is,
never use in-cockpit NextRad for tactical maneuvering through storms or navigating tight gaps. It shows where weather was. Use it for strategic, wide area avoidance only. Also, be aware it might block other displays like terrain or traffic sometimes due to color overlap.
so know its age, use it strategically. Are there other NextRad issues to know about? Abnormalities or limitations?
Yeah, a few. You can get ground clutter, false echoes from the ground near the radar, strobes or weird data spikes, sun interference, radar shadows behind mountains or buildings, even reflections from military chaff.
And limitations.
Base reflectivity doesn't show cloud layers well or tell rain from hail. The radar can't see directly overhead well, cone of silence. And resolution isn't infinite zoom in, and you see blocky pixels, each showing the strongest return in that maybe 1.24 mile square area.
Good to know. How about AIRMETs SIGMETs on the MFD? How do they look?
Usually shown as dashed lines outlining the advisory area, often color-coded by hazard type.
Is there legend?
Should be. Blue for icing, yellow orange for turbulence, green for IFR, etc. Makes it easy to see the geographic area affected without plotting coordinates. You can often click on the area to get the full text details, too.
And graphical METARs, how are they displayed?
Usually as little flags or icons right at the airport location on the map, color-coded based on current flight category, green VFR, yellow MVFR, red IFR, maybe blue for low IFR.
So you can just stand along your route.
Yep. Pan the map, see the current conditions at stations ahead. Quickly spot areas of marginal or IFR weather. Really helpful for diversion planning, too.
Sounds like data link weather is a huge leap in situational awareness.
It really is. Continuous updates, nationwide coverage, any altitude. Cuts down on radio chatter asking for updates, especially when frequencies are busy. An FSS briefer can only talk to one pilot at a time. Data link serves many simultaneously. Huge safety boost, if used correctly.
Let's talk about FISB specifically, Flight Information Service Broadcast. How does that work?
FISB comes over the ADSB network using the 978 megahertz UAT frequency. If you have the right receiver, it broadcasts a bunch of free weather and flight info into the cockpit.
What kind of info?
METARs, species, TAFs, NextRad imagery, regional or CONUS, NOTAMs, AIRMETs, SIGMETs, convective SIGMETs, special use airspace status, TFRs, winds loft, PIRMs. Quite a list.
But there's a big catch, right?
Huge EE catch. FISB products are for information only, situational awareness. They do not meet the regulatory requirements for official weather products for flight planning or decision-making.
So don't use FISB as your primary source.
Absolutely not. Never base a go-no-go or tactical avoidance decisions solely on FISB. Plus, the data can be significantly delayed, maybe 20-30 minutes sometimes. Check your specific equipment manual for its latency figures.
That's critical. Okay, beyond just FISB, what are the pilot's core responsibilities when using any data link weather?
It boils down to understanding the system. You have to know about product latency. Assume NextRad is at least 7-8 minutes old, maybe more. Use it strategically. Know the product update cycles for different things and your service provider's update rate. Recognize system failure indications. Understand coverage limitations, line of sight issues, low down for ground stations, satellite orbits, NextRad, gaps out west. Be totally familiar with the content and format on your specific display symbols, legends. Understand data integrity limits and disclaimers. Know how to properly use the equipment, could be checked on a flight test. And, really important, avoid information overload. Manage how much stuff you layer on the screen based on flight phase, workload, airspace, weather. Too much info can be as bad as too little.
So great tools, but they demand knowledgeable use. Official briefings are still key.
Still absolutely essential. No forecast is perfect. Data link adds awareness, but it doesn't replace thorough planning and checking multiple official sources. Each piece gives you part of the puzzle. You have to put it all together.
It really is impressive, though. This whole ecosystem, observations, agencies, technology forecasts, all working together to give pilots the best possible weather picture.
When you think about it, yeah, from that balloon launch or METAR reading
To the complex forecast model?
to the chart or the advisory or the image on your MFD, it's quite a chain.
Which leads to a final thought, doesn't it? With all this amazing tech, all this data, what are the new challenges?
That's exactly it. How do we make sure pilots can actually effectively use all this information, interpret it correctly, integrate it, not get overwhelmed by it,
Right.
especially as the tech gets even more sophisticated?
Making sure the human keeps up with the machine, essentially.
Yeah.
How will that evolve?
Yeah, how do we ensure this flood of data consistently leads to better, safer decisions? That's the ongoing challenge, I think. Something to keep considering.
Definitely something to ponder. Well, this has been a fantastic deep dive into aviation weather services. Thanks for walking us through it.
My pleasure.
And thank you for joining us. Until next time, fly safe.